Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I wanted to do a video on the Module 1 assessment. Everybody on my team has finished this test, so I wanted to go through because I know some kids are going to be at home, maybe lost, and they need some help. So this video is here. So anyway, let's take a look at these. One thing I gotta say is my kids really did a great job of underlining and highlighting keywords and stuff. So kudos to you. You guys did a great job showing work. Some people, I think they get a test in front of them and they hyperventilate. So we're going to work on that this year, guys, because there's no need for that. But I'll go through this with you, and hopefully you can figure out what you did wrong and how you'd fix it and prevent yourself from doing that again, because that's really the important part of learning. You know, you're going to make mistakes. You're in 6th grade, right? So yeah, you're going to make mistakes, but you don't want to keep making the same mistake. So that's what we're going to work on today. So anyway, the first question says, at a back-to-school sale, Sam finds t-shirts that are on sale for 2 for $24. What is the unit rate? Again, unit rate means the price for one. So in this case, shirt. So whenever you want to find unit rate, you want the price divided by the quantity. So in this case, we're going to take $24 and divide it by the 2 shirts. And when you take 24 and divide it by 2, and again, this fraction bar right here means division. So if you take 24 divided by 2, you're going to get $12 per or for every shirt. All right, and where did I get that unit? Right here. So I have dollars in shirts. So it's $12 per shirt, choice B. All right, the next one. The ratio of boys to girls in a classroom is 15 to 12. So boys to girls, that order that they give that to us is important. What is the ratio of boys to total? So a lot of kids got this question wrong because they just listed boys. What did they do? They did girls to boys or something, but it wants boys to total. So 15 was the number of boys because it said boys to girls 15 to 12. All right, so 15 boys to total. To find total, you'd have to take the 15 and the 12, add them together to know that there are 27 students. So 15 to 27. Choice C. A lot of kids goof this up because they weren't paying attention to the order that things are asked, and that is super important when writing a ratio. Number 3, in the cafeteria line, 28 students ordered tacos and 35 students ordered pizza. What is the ratio? It's looking for us to write a ratio of students who ordered tacos to students who ordered pizza. So we have 28 who did tacos and 35 that did pizza. Well, you're going to write that down and you're going to go, well, it's not over there, because you need to do one more step, which is to simplify. So I'm noticing some students are having trouble with this skill. What you're doing when you simplify a fraction is you're finding the biggest factor of each. So the greatest common factor, the biggest number that you could use to multiply to get up to 28, that you could also use to multiply when trying to get a product of 35. And that biggest number that they have in common, that factor, is 7. So if we divide that biggest factor out, you are going to get 4 to 5, right? 4 to 5, if we were to scale that back up, we could get to 28, or we would get 28 to 35. So 4 to 5 is the correct answer, choice A. Let's move on to the next page of your test. Question 4. Oh, one quick note, these test questions came from a variety of sources. One of the main sources that they came from was from New York State tests in the past few years. So these questions, some of these were, you know, coming straight from the state, and they're not terribly complicated. Some of them, other math teachers and myself worked on to kind of supplement and fill in the gaps where we taught certain things that we didn't necessarily see on a state test, because you don't see everything on there, obviously. So in case you're wondering where these questions came from, some teacher created, some state created. So anyway, question 4 says, a pet store sells puppies and kittens. There were 12 puppies and 5 kittens at the pet store. I think I made this one up. What is the ratio of kittens to total pets? So this one, I set this up to help sort out the kids who realize that this order is important. So kittens was asked for first. There were 5 kittens. Total pets, you've got to take 5 plus 12 which is 17. So 5 to 17 is the answer, choice D. Let's move on to question 5. A lot of kids, for question 5, it says percents can be converted into blank. A lot of kids said, well, they look for the first right answer they see, and then they forget, or don't bother to, I should say, read any of the other answers. So they said, okay, yep, they can be converted into decimals, and they picked A instead of reading that, yeah, they can also be converted into fractions, right? Because if we had, for example, 5%, we know it's 5 out of 100. We could simplify that down sometimes too, right? And ratios is the same thing as a fraction, so it is choice D, all of the above. All right, so don't get too impulsive and pick what you think is the first right answer and ignore that, there's a better answer in there. Number 6 we talk about a lot. It says, according to Mr. Mattingly, if you can't divide and you can't multiply, you must simplify. So that's talking about when we have a proportion. Let's say we had, for example, let's do 4 6s, and you want to figure out how many ninths that is. Well, you'd say, oh, well, 6 doesn't go to 9, right? So you have to simplify this. So 2/3, right? You would get 6/9. But you had to simplify first, otherwise you're not going to see that connection. When you guys get into higher grades, you're going to do something called cross multiplying, and I know some of you guys have some really great people in your lives that have taught you how to do that, but the goal, if you don't know how to do that, the goal of this method is to help build that proportional and ratio understanding so that when you move into more in-depth problems next year in 7th grade and 8th grade, they will, it builds on this, okay? So that's a mindset there. Question 7, Mr. Riordan travels at a constant speed of 70 miles per hour for 2.5 hours. How far does Mr. Riordan travel? So we know it's 70 miles in 1 hour. Miles per hour means in 1 hour. So he is going for over 2 hours. So if he's going 70 miles in 1 hour, he'd go 140 in 2 hours, but he's going over that amount. All right, so it can't be 140. We could eliminate that. And we know in 1 hour he's going 70 miles per hour. So it doesn't make sense that he would be going less miles than 70 in 1 hour. All right, and then choice C is just a ridiculous number. You could pretty much not know a whole lot about math and pick A and have that one correct, but I'm going to show you exactly how to do it. Distance equals rate times time, right? That's our formula. So you take your rate of speed, which is 70, and you take your hours, which is 2.5 or 2.5, and you multiply those, and you're going to get 175. So that's a formula right here that we learned in class and practiced quite a bit with. So some kids are trying to divide. You're not looking for a rate, so you're not going to divide in that case. Okay, the next question, number 8, says, if Mr. Whitley runs 54 feet in 8 seconds, what is his rate of speed? Well, we learned to find rate. You want to find something per something else. So in this case, we want to find out how many feet per second. So we can use the rate for speed formula, which is distance over time. So we're going to figure out 54 feet divided by 8 seconds. So when you divide that, you are going to get your answer, which is 6 7/75 feet per second, and you got that unit because right here it's feet divided by seconds. Now if you pick choice A, that's because you're multiplying stuff. You shouldn't multiply that because he may be fast, but that's that's a speed record there. So this should be like a turtle. And choice C, again, that's like astronomical. So a little common sense will get you a long way on these questions, but to find speed, you take your distance and divide it by time. All right, so I'm going to move on to question 9 here. It says the table below shows the number of green Skittles in bags of different amounts of Skittles, number of candies in bag, and number of green Skittles in bag. So the biggest mistake kids made here is that they were jumping up. They were like, oh, it jumps up by 8 each time. But what they didn't notice is this is not a jump up by 8. So you can't say 2, 2. Actually, you can here. Never mind. It's just this one is off a little bit. So I'm not quite sure what goofed kids up on this one. You want to really look at the connection between the candies and the number of bags. So if you take the number of candies in the bag, every time if you divide that by 4, you're going to get the number of green Skittles. All right, so 24 divided by 4 is what you're actually doing here. So you can finish solving that one, but if you take 24 and divide it by 4, you are going to get 6 as an answer there. All right, the next one. Jody's father's car used 12 gallons of gas to travel 456 miles. How many miles did he travel per gallon of gas? Well, you know, you definitely couldn't ask somebody who owns their own car this question and have them answer A, because if you have that that car, wow, that'd be great. That is totally unrealistic. And if you have C, I'd get rid of that car. So you've got to really kind of, for common sense purposes, narrow down to choices B and D. So we want to find out how many miles per gallon, right? So we want miles per gallon. So we've got to set up the miles on top, 456, and divide that by 12 gallons. So anyway, if you take 456 and you divide that by 12, 456 divided by 12 equals 38 miles per gallon. So on 1 gallon of gas, you would go 38 miles. All right, the next question. Jody's father pays $44.88 for 12 gallons of gas. What is the cost per gallon? This is a unit price question, so we want the money amount per gallon. So we have $44.88 divided by 12 gallons. When you do that division, hope you have your glasses on because it helps with division. I know, super cringy. I'm okay with it. You're going to get $3.74 per gallon. All right. This next question, a lot of kids got this wrong, and I'm not quite sure why, but you're going to start with what you know here. You have 5 apple pies for every 3 blueberry pies. Last week, the baker made 15 blueberry pies. We want to figure out how many apple pies did he make. So, or did he or she make? 5 apple for every 3 blueberry, all right? And we want to scale that up to 15 blueberry. So when you label this stuff, it's really easy to see where you should put these quantities. What's happening is a lot of kids are not labeling, and then they set it up incorrectly. So that is really the importance of labeling here. So you can look at this pretty easily. 3 times 5 is 15, and 5 times 5 is 25. So 25 apple pies is the correct answer there. Question 13 says, out of 20 athletes surveyed, 10 athletes chose baseball as their favorite sport, 6 chose golf, and the others chose hockey. They don't tell you a number of people who chose hockey, but we do know enough to figure that out. So we have 20 total people, right? If we subtract out the 10 that chose baseball, that means there are 10 left. But we know there are 6 of those that chose golf, which means 4 like hockey the best, all right? We want to figure out what percent chose hockey. So we know it's 4 people out of a total of 20, right? Because we know it's part over whole equals percent out of 100. Well, we don't know the percent. That's what our goal is to find out. So I'm going to put an empty box here, all right? So we want to scale this up to be out of 100. So you multiply it by 5. And 4 times 5 gives you 20 out of 100, so 20%. Another approach that you could use is once you figure out the 4, the key thing is you got to figure out it's 4 out of 20, right? So 4 out of 20, there's our part to whole ratio. If you take 4 and divide it by 20, you're going to get 2/10, right? So we can change any decimal to a percent by moving the decimal place 2 spots to the right. So that would be 20%. All right, so 2 options to get there. Let's look at the next page, which is equivalent to 45 over 75. So when you take that fraction, you can turn it to a decimal by dividing. That fraction bar means division. So 45 divided by 75. You always, on a calculator, you type in the top number first, then divide it by the bottom number. All right? If you were setting it up old school division way, you know, when you write it side to side, it'd be 45 divided by 75. If you set it up with this thing, which I jokingly call the gazinta, it would be 45 on the outside, and we're dividing that by 75. So anyway, let's see. So 45 divided by 75 is going to give you a decimal equivalent, when you type that in, of 0.6. So a lot of kids made the mistake of putting 6%. You've got to move that decimal spot or that decimal point 2 spots to the right, and that will make it 60%. All right, so this is not the same as 6%. That is nowhere close to 45%. And the reason people would get choice A if they mess this up is, I'm guessing if you take 75 and divide it by 45, yeah, that's where they're getting that answer, which you have to be really careful, and I can't stress this enough. You've got to divide your top number by your bottom number, so 45 divided by 75. If you were to scale 3/5 up, you would get, you know, multiply this by 20, multiply this by 20, you would get 60 out of 100, or 60%, or you would write that as 60%, or 6/10, or 60/100, which is mathematically equivalent to this guy right up here. So the correct answer there is choice B. The next question, pretty simple. You have the length of a poster that's 16 inches, and you want to convert that to centimeters. So you know that 1 inch is 2.54 centimeters. So if you have 16 of those, you've got to multiply 16 times 2.54, and you can do that again on your calculator. So, you know, you're going to have more centimeters than you have inches. So you could definitely, you know, kind of look at that and eliminate those two. This one isn't, you're looking for a number that's more than double, right? Because 2.5 is more than double. So it is choice D without even bringing that up on a calculator. That is your answer. All right, number 16, Samantha correctly answered 38 out of 55 questions on a math test. What percent did she answer correctly? So we are finding 38 part over whole, 55 total, right? So 38 divided by 55. If we tried to scale it up to 100, it would not work. It's not going to work that way. So we have to use the division method, because that 55 is not a magical denominator. Well, you're going to get 0.69090, blah, 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 blah. All right, so you got to move this 2 spots to the right, and that would give you 69%. All right, the next question, 17, Peter shovels sidewalks in the winter. He earns $24 in 3 hours. That means he, in 1 hour right here, earns $8. So if he's working 4 hours, we know we take our hours, multiply it by 8 to give us the amount of money. So 4 times 8 is $32. All right, the next question. A lot of kids had trouble with this one because they didn't set it up properly, and again, I attribute that to not using labels the way they should. So you know that Wyatt hiked 6 miles for every 2 hours. That's right in the problem. All right, so then you want to figure out 9 hours. So people are messing this up because they're putting the 9 on top. The 9 goes across from the 2. Because you have that labeled, you can see that. And you're going to see that that does not scale up unless you simplify. So if you can't divide or multiply, you've got to simplify this down. So figure out how many miles he can walk in 1 hour, which is 3, right? So 1 times 9 gives us 9, and we have to do 3 times 9, and that gives you 27 miles, which is your answer. All right, number 19, it says the ratio of students to adults on a field trip is 8 to 1. Now, anyone familiar with schools is you always have more kids than you have adults. So you are looking for where if you were to simplify any of these ratios, you would get 8 to 1. All right, I'm looking at this and I'm thinking I can eliminate immediately choice B because there's more adults than students. With a 1 to 8 ratio, students to adults, right, there should be 8 times. Oh, I have that backwards. Sorry. Should be 8 to 1. I said 1 to 8. 8 to 1 students to adults. That's not how this one works, right? That is not okay. So if you got that one wrong, I'm going to erase that. It is not choice B. That is a bad answer. Okay, sorry about that. a little distracted here. All right, so the ratio of students to adults on a field trip is 8 to 1, which table correctly shows this ratio for each grade. So it should be students are 8 times the number of adults. So it can't be B because we have, in that case, more adults than students, and we want 8 times the number of students and adults. So you have to look for the one where you essentially take the number of students and divide it by 8 to get the number of adults. This is too close of a ratio for that to work. All right, that does not simplify down to 8 to 1. If you take all of the values, 96 to 12, and you simplify any of these, 120 to 15, or 136 to 17, if you simplify any of those, you're going to get 8 to 1. All right, we are moving on to question 20. This question probably was one of the most missed questions of the test. It says the diagram below shows the percentages of people attending a football game who are supporters of either the home team or the visiting team. And 20% were visiting, 20% were there to support the visiting team, and 80% were there to support the home team. It then tells you that the total number of people attending were 64,000 people. We want to figure out how many people were supporters of the home team. That's important. So we are looking at this. We're going to use part over whole equals percent out of 100. So let's set that up based on what we know. So we know the whole amount of people. The total amount is 64,000. Everyone included 64,000. We know the 100, that's a freebie. Now, we need to figure out the percent, which that's right up here. So we're looking for the home team. So we want to look right here, home team, that's 80 out of 100. And we are missing the part that supports the home team because this was home team on top, and this was total people there on the bottom. So we are looking for this connection. So we look from the completed side to the part that is missing. All right, so I'm not sure where I was there. I had to pause it for a second. So anyway, we are looking for the connection from the completed side to the incomplete side. So I want to know, what do I multiply 100 by to get 64,000? So if you take 64,000 and divide it by 100, you're going to get 640. So you're taking 100, multiplying it by 640. Do the same thing up here. And when you take 80 and multiply it by 640, you are going to get 51,200. And these should have been commas. Blame Edoctrina. Good job with the typo. All right, let's go to question 21. Kim Lee earned $17.50 for 2 hours of work. Which table shows the relationship between the number of hours worked and Kim Lee's total earnings if her rate per hour is constant? So when you look at this chart, the key thing that will help you eliminate a few of these answers immediately is that we know it's $17.50 for 2 hours. Well, if you look here, that's showing $17.50 for 1 hour. This is showing $17.50 for 1 hour. That is clearly not what it said. All right, so now we've got it narrowed down to at least just the two tables that have 2 hours being $17.50. Bless you. And then we want to look for, a chart that accurately conveys that for each hour worked. If you look at choice C here, you'll notice it's $16.50 for 1 hour, $17.50 for 2. 3 hours is $18.50 and 4 hours is $19.50. So each hour this person works, they're only getting $1 more. So it's like, that's not what that says. We want 1 hour times $8.75. So 2 hours times $8.75 will give you $17.50, and 3 times $8.75 will give you $26.25, and 4 times $8.75 is $35. How you would get that is, 2 hours is $17.50. So $17.50 for every 2 hours. When you divide that, you're going to find out that 1 hour is $8.75, right? So you can easily then scale it up from there. Let's move on to the next one. A lot of people miss this one. When it says a bakery sells 5 apple muffins for every 2 bran muffins, they're giving you a ratio. And all of the ratio tables should be based off that same value. You're looking for the one that has accurately showing a 5 to 2 relationship. So you'll notice that some of these immediately have a 5 to 2 relationship. Some of them look like they do at first, but they might not as you go through the entire table. So what you have to do is do a lot of simplifying of ratios to see if they all scale down to 5 to 2. So 5 to 2, does that equal 10 to 12? Well, that doesn't even make sense, right? Because the top number is bigger than the bottom number here, right? 5 is bigger than 2, so that 10 should be bigger. We need a number bigger than 12. So it can't be A just based on that alone. Choice B, we have 10 to 4, 15 to 6, and 35 to 14. So 10 to 4, when we simplify that, we're going to get 5 to 2. When we take 15 to 6, they're both divisible by 3. You're going to get 5 to 2. And then 35 to 14, I'm noticing they're both divisible by 7. And you're going to get 5 to 2 that way. So your correct answer is choice B there. A lot of people got trapped in choice C and, well, choice C because they see this and they're like, oh, look at, there's the answer. Well, if you take 18 over 8 and you simplify that, you're going to get 9 over 4. That is not 5 to 2, so it can't be that one. 20 to 4, you're going to divide them each by 4. You're going to get 5 to 1 on that one. So that one's not going to, that's not going to work either. So you want choice B. Last few questions here. It says, which of the following is equivalent to 6/10? Well, remember, when you have any decimal, you want to change it to a percent. You've got to move that decimal spot 2 spots to the right. If you chose A, you didn't move it far enough. You moved it 1 spot. Right? If you chose choice B, you just slapped a percent sign at the end, and that's not how that works. And I'm going to let you figure that one out from there. Which of the following is equivalent to 42%? Well, again, if you take 42 hundredths, that's going to transfer to 42%. This is choice A is 42 thousandths. That's not going to work because that would be 4.2%. That's not what we want. Right, 42 over 100, that looks like what we need. This is 4/10, so that would be 0.4. And 4.2% is not the same as 42%, totally different. So I'm going to let you answer that one from there, but there you go. And the last question of this test says, of the 20 students in Mrs. Lehman's first period math class, half of the class got a perfect score. What percentage got a perfect score? So you need to know that half of something, 1/2, equals what as a percent. So what amount out of 100, and you can figure that out from there as well. So anyway, I hope this helped you get your test corrections done, and I will see you guys later. Thanks for watching Math with Mrs. Lehman. If you've already subscribed and you've already liked, please do me a favor and hit the notification bell so that you can be alerted to all of my new videos. Thank you very much.